If I asked you if 6 exists in this particular array, you would say yes, because your eyes would directly move over here and say, yes, 6 exists. But for computers, it's not that simple. They have to look into every one of these things one by one step at a time. We have optical vision, so we're gonna just see something that looks like this, and then maybe even out of something really huge, we'll be able to figure out where 6 exists. But for computers, it's different. It's like a closed box that computers have to open each time and see if the number that exists is what it is. So it has to open this box and it's 5, and then it has to close this box. I mean, it could remember it if you were to maintain any sort of variable that you're going to remember, and it's going to go to the next one and then see if uh, what if the next number is 6, it opens it, it's not 6, and what happens is it goes to the next one, and then it goes and sees if it's 6, and then the target is reached, right? So the computer says, yes, we found 6, and we can terminate the loop. So this is what linear search is, which is to sequentially search the data, okay? There isn't a brute force solution for any of this, so this is the most simplest problem in the computer science, uh, which is to find in an unsorted array, by the way, which is not sorted, because if it was sorted, we could do something else, which we'll talk about in the next video. In this video is that you have to go sequentially, one by one, like one step at a time, one step at a time. So one step at a time. So how would you solve this in like how do you code this up, right? The code for this, right? So let's write the code for this, right? So that would be I'm just gonna write pseudocode so that you can just literally type this in any language, which is to inside a function, you can just define that, or if it was, you can just define a for loop. Okay, if you don't know what a for loop is, you can just define the loop from a given range. You can set I is equal to 0 and I is lesser than n. Because in computer science, we always start the numbers with, I mean, the indices in an array from 0, which is 0, 1, 2, 3, 4, and 5. So although there are 6 elements over here, we're starting with 0. So if there is 5, which is what you see at the last, which means that there exists 5 plus 1 element. You can count that, okay? 1, 2, 3, 4, 5, 6. So there is totally 6. So that is why we go with I lesser than n, which is lesser than 6, which is going to be until 5. And then we're going to do plus plus plus, which is that incremental factor, okay? So it's going to increase starting from 0 to 5, and it is going to check if the array of that, I mean, and this is the indicing. So this is the indexing method. So you can just enter the index. This is the array. Let's say there's a lot of things that I had to explain, but this is the array. And if the array of this particular index, which is 0, 1, or 2, or 3, or 4, and if that element is equal to the target. So in our function parameter, we'll have to give in something, right? Like you call a function and then say, this is the target that you have to figure out. So I'm going to pass a target parameter. And if it's equal to the target, that means that you'll have to break the loop. You can maybe print element found at, maybe you can add array of I position at maybe like plus at, and then say position I. There's a lot of things that is going on, but I hope it makes sense. Um, yeah, and then you can just break out of a loop, right? And then we're not going to put an else condition, but we'll just say else, or maybe well, we're not going to put an else because there might be other elements that it's going to look for. So this is the for loop that ends, and if element was not found, we could have had next. Okay, we'll just not go through there. We'll just assume that the target always exists. So this is the code for the linear search. And so just going to explain a lot of topics, moreover, and this is going to do a for loop. And so, why did I put a break here, if you may ask? It's because if it goes from here to here and then here, so if the element exists and if it's just one element that exists, why do you have to continue looking, right? So I'm just going to print the element and the index that it's located at, which is 2, right? Which is at over here. So it's located over there, and then it's going to just break. Instead of traversing more and then computing, wasting the compute energy of the computer, which would not be good, right? So we'll talk about something called time complexity. It might be too overwhelming for beginners. What is time complex? It's like the dimension that you would use to refer. Time complexity is the it's usually represented in 3 different formats. Bigger is the most popular one, which is used to identify the worst case scenario, which in our case, the best case could be that we found the element in just one try. And the worst case is that it took 6 tries. Okay, so 6 is basically n over here. So the this is the best case, right? And this is the worst case. So when we define anything with O, we're trying to find what is the worst case in this possible scenario, which is n. So what is the space complexity? We're taking n number of space. So the space complexity is of n. So thank you for watching this video, and we'll be progressing a little faster throughout the video. The whole idea of this is not to just teach DSA, but just to involve a lot of curiosity, because there's a lot of things that programmers that should understand more than to just learn how to code. It's to understand problem solving skills, which is much more important than just learning how to code, right? So thank you for watching and see you soon.